Good morning, everyone. Yes, we seen the handoff process. In that handoff, we seen the soft and hard handoff. What is the actual problems will be occurs in soft and hard handoff? That all the concepts we see in previous video. Now this is the some multiple axis, and that is the useful for the handoff process. That is the today's topic. That is the Fdma, Tdma, and Cdma. In today's topic, which television service is better for you? The question mark will be added because we have to learn which service we have to require because every day it will be related to some frequency axis, time axis. This is some wireless network axis for the CDMA, and then which will be better? It will be shown in one video. We first one you check the one video, and after that we will go to the in brief in details, that is what is the Fdma, Tdma, Cdma. The video will be that is the animated video, and we will clear all the concepts by this video.
All of us get excited when we see the symbol. But how does it work? Ever wondered how millions of subscribers are served by telecom operators simultaneously? Hi everyone. Welcome to the world of long-term evolution. Today we will show how multiple users access network using multiplexing.
In the last video we have shown how two signals were combined over a common pathway in duplexing. So, what exactly is multiplexing? Multiplexing is the process of combining multiple signals and transmitting them over a common channel. Then what is multiple access? When multiplexing is used to allow multiple users to communicate over a single common channel, we call it multiple access. In other words, multiple access is nothing but the application of multiplexing. So here's a Wi-Fi hotspot sharing its internet connection among multiple users by providing them a frequency block over which they can transmit and receive data. The greater the size of this block, greater is the throughput. Telecommunication systems, which mostly use radio waves as a communication link with end users, have employed several ways to share this resource.
Fdma, which uses frequency division multiplexing, provides chunks of the frequency spectrum to each user for data transmission. Generally, the data is generated at baseband and modulated at varying radio frequencies. Guard bands are introduced to avoid any interference. AMPS, or the first generation analog systems, used Fdma to provide each user a duplex channel with one-way bandwidth of 30 kHz. Tdma, which uses time division multiplexing, allows multiple users to share a common frequency band by allocating different time slots. Thus, in an N-channel Tdma, where each channel is given a time slot of 2 seconds, signals coming from each user will be transmitted at intervals of N into 2 seconds. This technology was used in the 2G systems like GSM, GPRS, and EDGE. Each user was provided one of 8 Tdma slots in a bandwidth of 200 kHz. Dynamic resource allocation meant more users could be supported, but each channel could support only 8 active users at a time. CDMA based on code division multiplexing is a technique in which the data bits are modulated by a high-frequency orthogonal sequence of bits such as wash codes or pseudo-random codes such as gold codes to spread the signals over a large frequency band. Multiple such signals from different users are then transmitted over the same frequency band. In order to retrieve the signal, receiver must have the same spreading sequence, which is multiplied to this composite signal in a process called despreading. This makes CDMA very secure and robust. It was used in 3GPP2 standards such as CDMA and CDMA Evolution Data Optimized standards. Wideband CDMA or WCDMA spreads the signals over an even higher bandwidth. This was used in the 3G standards of 3GPP from UMTS to HSPA+, where the available bandwidth was 5 MHz compared to 1.25 MHz used in CDMA. There are other multiple access techniques like wavelength division multiple access, which is used in fiber optics, and space division multiple access, which refers to spectrum reuse over non-overlapping areas.
As the number of users and their demand started growing, communication networks evolved from 1G to 4G. Radio part was significantly enhanced from GSM to HSPA+. Now, focus was shifted towards better spectral efficiency by using higher modulation order like QPSK, 8PSK, 16Com, 64Com, etc. WCDMA improved upon some of the problems of earlier generations like, first, low data rates. In GSM, effective bandwidth for a user was only 25 kHz. Second, congestion at peak hours, as the frequency chunks and time slots were very limited. Third, resource wastage. Resources remained idle when users were inactive. Fourth, poor spectral efficiency, due to guard bands and guard periods used for avoid interference. But, exhaustion of spectrum, need for even higher data rates, and spectral efficiency lead us towards Fdma. Fdma comes with several advantages over WCDMA like bandwidth scalability, carrier aggregation, low interceivable interference. Fdma uses orthogonal subcarriers equally spaced at 15 kHz. Users are provided a subset of these subcarriers for data transmission. Unlike Fdma or Tdma, Fdma allows the users to access variable bandwidth depending upon their resource availability. Also, since these subcarriers are orthogonal, there are no guard bands between them. It was first introduced in Wi-Fi, and subsequently in WiMAX, by IEEE, but as WiMAX lacked backward compatibility and support for mobile wireless at its inception, operators remained stuck with WCDMA. This changed with the introduction of LTE, which brought Fdma to the forefront of today's mobile networks.
So, today we showed what were the different multiple access techniques that were used in various generations of wireless communication. In our next video, we will dive deep into OFDMA and SCFDMA, the two pillars of 4G. Hope you enjoyed the video. Don't forget to subscribe to our channel to stay updated. Happy
I hope you understand at least what is the Fdma, Tdma, Cdma. We move towards the in details. We see the in details. This is the types, that is the Fdma, Tdma, Cdma, and Sdma. That Fdma, the spectrum is divided into many smaller channels. It is divided in some frequency slots in smaller channels. In Tdma, it will be used in different time slots in multiple users. In Cdma, it is a unique coding up to 64 subscribers, and it will be can share up to 1.25 megahertz channels. That is the SDMA related to uses highly directional antennas to pin out users and rejects other on the same frequency. That is the space division multiple axis. Now we go to the stepwise. Here is the given Fdma frequency division multiple axis. Fdma is the system bandwidth is divided into a number of non-overlapping channels. One channel for each user. Guard band is left between every two channels. We see the details. This is the user in 1G cellular networks, that is related to AMPS we seen in previous video lectures. That is what is the AMPS. AMPS, it is the user in 1G cellular network. Here is the mention. Here is the divided some slots, frequency slots in between the red and green color, the spaces, that is we are calling as then guard band. Guard band, it is the part of, this is the one user, second user, and third user. In between the users, no any interference. Hence we here we getting the one guard band. That guard band role is the it reduces the interference from the two users, but sometimes it is a very disadvantage in the Fdma, that is the crosstalk will be happen in the Fdma. This is not reducing the total noise guard band, but some reducing some obstacles, some noise will be removed in the guard bands. But crosstalk will be happens in frequency interference by frequency interference in the Fdma. In Fdma, the difficulty of assigning multiple channels is due to inability of the radios to simultaneously the demodulating the periods, demodeling the received signals. The transmission in Fdma is continuous over time. Fdma is also used in OFDM systems in multiple carriers used for each user. Having some features we see in the stepwise. First one, Fdma we seen here in diagrammatically. Next one, we moving towards the time division multiple axis. The word itself says that is the time. It will be multiple users using in some different time slots. This is mainly based on the time factor. Here given frequency and time, that is the x and y axis. It is the taken some slots. It is depends on the some time factors. The entire system bandwidth is allowed for all users. The entire system, whatever the bandwidth, it will be allowed for the all users. It is an assigned for a specific time slots and specific time duration. That is the frequency and time division multiple axis. It will be used in a 1G and 2G generation. In between the we mostly removing the gaps. It is the user and AMPS technique as well as an GSMG and GPRS technique. For that purpose, it will be used in frequency and time division multiple axis. Here it will be given in, it will be mostly used in 2G cellular network for the GPS and GPRS. That is the frequency and time division. Here it will be divided in time slot as well as in frequency slot. That is the using of some guard band and some time duration. That is the already we cleared that what is the role of guard band. Guard band, it is the not interfacing, not interference with some frequency from first user to second user, and it will be divided in some different time slots. And mostly it will be used in 2G cellular networks, that is the GPRS and GSM. That is the taken one image that is related to frequency and TDMA. So what will happen, some number of users in using of different types of frequency and different types of time duration. In that case, what will happen in the graphical representation? We are tried to here given one image. Now we move toward the CDMA. CDMA, it is the third generation, that is the 3G. It will be related to the CDMA, WCDMA, it having the low data rates. Mostly it will be used in UMTS to HSPA techniques. CDMA is an important technique. It uses the whole band for the whole time. It is an important technique for wireless network access technique. The information signal is spread using the spread spectrum technique. Signal is multiplied by an orthogonal and non-orthogonal spreading. Here is the every transmits on top of every, that is the whole bands will be given in CDMA, mostly in wireless network access. When different types of users will be different users will be preferred, that is the whole band, that will be shown in graphical representation. That is the some different users preferred as. It will be used in 3G cellular network, that is the WCDMA UMTS techniques. That is the third generation of. This is Fdma Tdma and Cdma, it is some hierarchical 1G, 2G and 3G. It will be how to reduce the and how to develop the techniques, that is some types. Here is the given, yes, it is different codes and you know the right code, then you can receive the person transmitting with code, means using of one code, that is for related to users. Here is the given one example related to some rooms, that is the FDMA. Large room will be divided into small rooms. One large room is there in when you divide it in small rooms. In between each pair of people takes turn speaking. In TDMA, the large room divided up into small rooms, but three pairs of people in per room. However, each pair gets 20 seconds. Means we are given the time period, time duration for the person's users. It will be divided in same FDMA, divided in small rooms, but we given the times. CDMA, there is no any small room. Everyone is speaking in different language. There are different types of users. Whole band is of that user. The voice volume is minimized, then number of people will be maximum. It will be n number of users will be connected in the serial. This is some taken one example related to the small large room. It will be divided in small for the FDMA, TDMA. It will be same, but we given the time period, and CDMA it will be no room, but it will be given freedom for the every users. This is the graphical representation will be TDMA, FDMA, CDMA. The frequency and time x and y axis, what will be happen in FDMA. The frequency will be divided in frequency slot. It will be divided in time slots, and it is the whole band of that. And this is the color banding, means it is the different types of users will be shown in graphically. This is some general specifications of TDMA. The receiver having 869 to 894 megahertz, transmitter having 824 to 849 megahertz. It will be having 832 channels spaced 30 kilohertz apart. 3 users in per channel. Whatever the channels will be divided in time divisions. 3 users in per channels. It having a DQPSK modulation scheme. The bit rate is 48.6 kbps bit rate. This is the some general specification digital AMPS, that is advanced mobile phone system. It uses some time division duplexing TDD usually. That is the bit rate is 48.6 kbps. It having 3 users per channel. Some advantages of TDMA. There are lots of advantages in TDMA in cellular technologies. It can easily adapt to transmission of data as well as voice communications. It has an ability to carry 64 kbps to 120 mbps data rates. Here will be given in details, that is the flexible bit rates, no need of precise narrowband, no frequency guard band, easy for mobile and or base stations to initiate, execute, or a hands-off, extended battery life, that will be given in detail. It provides users with extended battery life since it transmits only portion of the time during conversation. TDM is the most cost-effective technology to convert an analog system to digital. It is a very good advantage for the TDMA. It also having some disadvantages in TDMA, that is the requires wider network for the synchronization purpose, time synchronization, multi-part distortions having demands for a high peak power and uplink in transient mode. The major disadvantages in TDMA technology, that is the users have predefined time slots when moving from one cell site to other. If all the time slots in the cell are full, the users might be disconnected. and this will be happen in your daily routine. We know this is some general specifications of Fdma. The receiver side at 69 to 894 megahertz. For the transmitter side, we need to 824 to 849 megahertz. 832 channel space for 30 kilohertz. 3 users per channels. This is the given uses for the frequency division duplexing, that is the FDED, and ISA for the intersymbol interference is very low. That is the specification for the FDMA. FDMA is not the timing problems that TDMA has. Due to the frequency filtering, FDMA is not sensitive to near far problem, which is pronounced as CDMA. It requires high performance filters. The disadvantages to the advantages for the FDMA. It having no need for network timing, no restrictions, no capacity increase can be obtained by the reducing information. It is a very fairly efficient the number of stations. The algorithm is very simple as from a hardware standpoint. Channel is not in use, it's sets idle. Channel bandwidth is relatively almost 30 kilohertz. It also having the disadvantage, that is the crosstalk, which will be already seen. The crosstalk will be happen because of some frequency interference, and it will be disrupt as well as disturb the transmissions. It requires RF filtering and minimize the adjacent channels. Maximum bit rate per channel is fixed. Same for the general specification of CDMA. The receiver power 869 to 894 MHz, and for transmitter power 824 to 859 MHz. 20 channels spaced for 1000 and 250 kilohertz apart. Almost 798 users per channel. It will be used a modulation scheme, that is the offset QPSK, and QPSK, that is the used for the modulation scheme. The bit rate is almost 1.20 Mbps. IS-95 is the standard, and it operates almost 800 and 1900 MHz frequency bands. This is some graphically slots the data input, the bit stream, what happen in the spread spectrum in multiple axes. The from transmitter and receiver side, the graphically and waveform oriented, we shown here the what is the spread spectrum and what will be happen in multiple bands. Some advantages of CDMA, that is it having many users use the same frequency in same time slot as well as some same frequency slots. It having multipath fading substantially reduced by a large signal bandwidth. No time limit for the users. It is easy addition for more users. It is impossible for hackers also. Better signal quality for CDMA. It having no sense of handoff when changing the cells from one band to other band. This is some disadvantages. It having no any dropouts occur only when the phone is at least twice as far from the base station. It is used in the rural areas where the GSM cannot cover. Another advantage is its capacity. It is very high spectral capacity. The disadvantages in CDMA, major problem in CDMA technology is channel pollution, where signals from too many cell sites are present in the subscriber phones, but none of them is dominant. Here is the user increases, overall quality service decreases, self jamming, some near far problem will be arises in CDMA. The cell structure we seen the cell structure. The cell structure, that is the macro cells and mm, macro and mini cells we seen pico cells also, that is the some cell structure we see in every cell structure we require some control unit and some base stations. The and that all the cell structures will be required for all the types we seen in details. What is the advantage of cell structure? That is a higher capacity and higher number of users, less transmission and having power needed. It is decentralized and base station deals with interference. But some problems will be occurs in cell structure, that is the fixed network needed for the base stations handover and changing from one cell to other necessary, interference with some other cells. It will be given in details, that is the frequency reuse. The frequency reuse the process which the same set of frequencies channels can be allocated to more than one cell. That is the clusters. The provided cells are we are calling the clusters. It will be separated by the groups of cells in different distances. For the number of channels we are having one formula, that is the F equal to G, and that is the G, it is the channels in a cell, and N is the channels how many clusters, that is the 3, 7 or 12. The total channel capacity in given in C, that is the M, that is M is the cluster in given area. What is the area of that cluster and how many channels, how many cells in that one cluster, that is the C and that is the related to totally about the Fdma, Cdma and Tdma. It will be given in details and cell structure and the details of advantages, disadvantages and what will be problems occur in cell structure. What is the bit rate and what is the frequency band we will see in details. That is all over about the today's lecture. Thank you.